I'm using crazy glue and thread line after line to go over the clay of the bone. After I'm done with this, I'm going to do the other side, and then I have to cut it in half, remove all the clay, epoxy coat both sides of the casing to strengthen it, and then reattach the two sides, and they'll be hollow and super lightweight. The thing that sucks about this is the cure time of the crazy glue. You have to time it just right, and always like set up a new section that can cure. Like, it needs like 30 seconds before it starts getting really tacky, so you have to fit in a certain time window. You got to constantly be thinking ahead. It's really annoying. That's why I'm using so many threads, so I can get as much in as possible during that curing window. I tried Super 77 spray-on glue, but it didn't work. Just got everything sticky. At least this dries after a while. I'm able to do fingers way faster, but these bones are just brutal. These big bones. You know, I can get a lot more detail doing this than with just sheets of fiberglass. There's no way I'd catch all this intricacy with fiberglass. So this technique is the best way, I think, to capture fine detail with composite material strength and all the benefits that that brings. Such as the extreme lightweight and flexibility. It will still be rigid, but it can flex a little bit if needed without breaking. These bones, I mean, they're the thickness of a single width of upholstery thread. So as you can imagine, this is an extremely thin-walled bone. Like, it's like an egg. It's like the thickness of an eggshell. And it's still strong even though it's hollow, because the air that's trapped in the center of it is sort of like when you screw the cap on a 2-liter pop and try to step on it. Unless if the air can escape, the air itself forms the center core. So as long as it's airtight, this thing is just, you can like stand on it, just like you can stand on a 2 liter of pop. I need it to be lightweight because servo motors are not that strong. And so I want all the bones to be hollow and extremely lightweight. That will really help a lot. You can see that I just I sculpted it up until the halfway mark. You can see the bottom half I didn't touch. And also I put all these supports in here to capture the curvature of the clay. So these are just like little supports I stuck under it as shims so I could get the curvature of the bone correctly. The clay is very flexible, so I just had to sculpt it in place after I got it just right. I'm sure there are easier ways to do this. The way they make like fishing poles with graphite, they I think they have some kind of machine that vacuums the how do they do it? So they take like a mold and then they apply the graphite with the epoxy, and then they use a vacuum in a bag to suck it and like smash the graphite into the mold, and then they let it cure, and then they just somehow pop the mold out. But I don't even know how that would work with this. It probably could work, but even graphite would be more heavy than this. Although I would be willing to do something like that, but this is what I have available right now. I also thought about 3D printing, but I think this is a lot stronger than 3D printing because this is going to be like epoxy coated inside and out. And 3D printing is just plastic. Plus, I don't own a 3D printer, so I was able to make this in one day. It's not like I'm mass producing robots, it's just the one I'm making, so just gotta be patient and get through it. This is the forearm, by the way. This would be where this is the left hand, and this bone is inside here. This bone is inside here, and that's what it looks like. I'm making this exactly to scale with my body because I'm just gonna make the robot look just like me if I can. That's the plan anyways. What I was doing before is I had 5 strings going at once, so I would get like 5 in a row and then just go all the way down. But now that I'm in this small area, I'm just working with 1 string. I cut out the rest. You know, the best thing would just be to take a piece of cloth and just go right over it, but that wouldn't capture all the fine detail, all the little ridges and everything. So that's why I'm just doing 1 string at a time. This has got to be like the slowest way to sculpt, but it's incredibly powerful. You can see all these finger bones I did. Here's a finger bone. That's like a thumb bone. And you can see it's really glossy because I coated it in epoxy after I was done. And this is super lightweight. It's not completely finished. I still got a gap in it. You probably can't see it. But yeah, so I got all these different finger bones on here. And once like I plan to make the thumb and the wrist, which has a ton of little bones in it, and then this is the forearm. And I'm going to be able to connect all them, get them hooked up with motors, and start planning out like where all the motors are going to actually be connected to the bones, and how I'm going to connect all the all the strings that go from the motor to the different tie-in points, just like ligaments. The motors are going to like tie in somewhere with the string, and then as the motors wind, they pull the string, raising the arm. So it's like a pulley system. And I'll be able to start messing about with that as soon as I get just a few more bones done, so I have a place to start connecting motors and stuff. For ligaments themselves, I'm going to be coating every single bone in spandex or Under Armour, and then I'm going to be like bridging one bone to another with a sheet of spandex, and I'm going to sew the spandex into the spandex that's on one bone and then into the spandex on other bones, so that there will be a spandex spanner connecting the different bones. And that will work the same way as a human ligament works, in that it will have some give and flexibility, but it will also prevent the bones from coming out of place. So that's the plan for that. I would be able to do this faster, but you're really relying upon the glue kind of taking hold before you let go. Like, you have to press and hold for a second for the glue to catch on good. You got to put some pressure on it, because this glue is like, it's sticky, but it's not that strong until it starts to really like bond to the thread as you put it down. This is just normal upholstery thread I'm using over clay, and it's just normal super glue. All stuff that is cheap, readily available, and then I go over it at the end with just epoxy from the hardware store. I just squeeze a little bit, stir it up, and then I actually use my gloves and fingers, and I just rub it all over the bone. And that gives it a ton of strength. After all the clay is out of it and it's hollow, it needs the epoxy to really strengthen it. And I put that on the inside and outside of this shell. If you're wondering why I don't just put glue over the clay, dig out the clay, now I've got my hollow shell, and then just put epoxy over that. The reason for that is this upholstery thread has tremendous tensile strength, and it's long ways going with the bone, and so that tensile strength will prevent the bone from snapping in half. It's gonna just make it extremely strong. If you think about like the way they pour roads, they use steel rebar, and then they put concrete on that, and the steel bars give a lot of tensile strength to the concrete, so it doesn't crack and break. It makes it like 10 times stronger than just plain concrete. And the same principle applies with putting all these thread sheets with the epoxy instead of just a bone made of nothing but glue. Yes, this is going to be a full skeleton. It's going to be life size, and I'm just going to use myself as reference. So, and I'm not just building a skeleton to learn about anatomy, I'm actually building a robot with a skeleton as, I mean, it's going to have like a similar design to the human body. So it's going to have all the bones the body has, like every single bone in the body, except I'm going to take some shortcuts, like when it comes to like the spine. I'm probably gonna just, like, I don't need to sculpt every little spinal cord segment, but almost every bone in the body is going to be anatomically correct, and I'm going to have these little motors that will control everything, and they will work just like muscles do. And I've already got all the motors and all the stuff purchased and ready to go, so as soon as I get enough bones done, I can start mounting motors and start playing with that, start testing the movement, and that's going to be where the real fun starts. Like, showing people me sculpting is kind of boring. I mean, it's educational if you ever wanted to sculpt something very small with a lot of detail that's very strong and lightweight, which that's kind of a specific thing. I don't know if anybody would need something like that, but it's great for anybody into robotics to be able to do that. But the real excitement will come when I start animating these bones. It's going to look insane because it's going to move just like a human. And it's going to be pretty cool looking. I feel like engineers just want to make everything like with nuts and bolts. And my design is going to be just very organic. I'm just totally plagiarizing God here. I'm just making everything the same as our bodies that I can. I wish there were artificial muscles like that work how our muscles do, but that technology is not there yet. So I'm just going to end up using servo motors to pull little strings that then pull the different bones the same way a muscle would pull the bones. And I've got a bunch of drawings and stuff of how that's going to all work. And I've already tested it and it works great. I tested it on a finger joint. So all this is like a necessary evil. I mean, it's kind of fun, but it seriously takes forever. But it will definitely be worth it when I have these bones that are basically unbreakable and weigh nothing. I think that by making my robot extremely lightweight, it has a better shot of being able to do things like jumping that a lot of the top humanoid robots you see on YouTube or whatever, they can't do that because they weigh a ton. Like, literally, they're all made of metal. This thing's gonna weigh like nothing. The only thing that has weight will be the servo motors, and those aren't that bad. Those would be like the only weight in the robot. So after I sculpt this, it's going to be as thin as an eggshell because it's just the width of literally a string. Because this is only one layer deep. I didn't overlap the string. They're only next to each other. So once I dig out all the clay, it's like a eggshell, and it's actually flexible a little bit. But it's going to be super strong because once I connect the two halves and it's airtight, the air that's trapped in there ends up giving it body. Like, it's just like a bottle. Once the cap's on there good, you can't break this. This is just flexible plastic, but it's super strong. It doesn't break, it doesn't crack because it's flexible. And, you know, this has air inside it. It just, you can't break it. So that's kind of the same principle. And it's going to be stronger than this, though. Particularly because this is, like, really, like, big and extra thin, like, super thin. This will be pretty thick, like compared to that, it will be thicker because I'm going to be coating it heavy with epoxy. And I'm coating the inside and out with a couple coats of epoxy. So it's actually going to be really strong. And I've already tested the strength on a bunch of little finger bones, you can see. Like, these are really strong. Now this one's not completely done, but I mean, you can stand on these bones. You can jump on them and they won't break when they're done. That's how strong they are. So, and they literally weigh zero. Like, if you put it on um, a postal scale, it doesn't register at all. They weigh nothing. They're like air. And they're extremely strong. If you look at like how they make bikes for Olympics and stuff like that, they use all like composite graphite. Like the most expensive bikes are made for lightweight and strength, and this is kind of the same concept, except I don't have like the vacuum seal and whatever. I'm just using it out of strings. That's available. I don't have a machine that could do this, like using like a vacuum and whatever they do. Well, Asimo is, first of all, I'm trying to beat Asimo. Like, although by the time I finish this robot, which could take me several years, they might have a way better robot than Asimo. But I think this robot's gonna be a lot better than Asimo. Like, I think Asimo, like, actually, I'm impressed with how he moves, but I hate how his knees are always bent. Like, it looks terrible. Just straighten your knees already. And I know they do that for stability, but that's just lazy coding. Like, you can program it to make those minor adjustments when it feels like it's falling. You can code it to not fall. Like, you don't need to have the knees bent at all times. It looks terrible. See, but the problem is, the guys doing Asimo are not artists. They're engineers. So, they don't care about beauty, they care about function. They're like, okay, he walks and he doesn't fall, we're happy. But then everybody watching it on YouTube, the whole world is the audience, is like, why does he look like he's squatting at all times? And why doesn't he look like natural and smooth when he moves? According to them, they probably think he moves perfect because he's not falling and blah blah blah, but you know, I'm an artist, so when I make my robot, it's gonna move like a ballerina. It's going to look graceful. That's the plan. Now, that's going to be a matter of my coding skills. And I am an experienced computer programmer. And I'm hoping I can rise up to the challenge. I'm kind of a jack of all trades. I know it worked. And I've done a little bit of everything. So, what's my background? It's kind of a hard question to answer. I mean, depends on how far back I go. I've been kind of just doing all kinds of stuff with technology, computer programming, web development. I've been an artist, like I've been a sculptor, I've been a painter. I've done a lot of 3D sculpting, like 3D software development. I've just done a lot of different stuff. I guarantee you, I've seen like every YouTube video about robotics, so I'm kind of like looking to make something better than everything I've seen. Now, I believe I will. I believe that if this robot, how I see it, were done today, it would outperform every robot in the world right now. But because of the speed of technology, by the time I finish this in like 6 years or whatever, it's not going to be the best anymore. Well, it could be, but I'd be surprised. Like, there's probably going to be some really... That Pet Man robot is the best one I've seen. Like, that's the closest to what I would like to do for a robot. Boston Dynamics are like the best robot makers that I've seen. I love those guys. Do I think it will be the most beautiful? Well, yeah, I mean, I think that making a robot that looks like a machine, machines are made by man. Beauty is nature, beauty is what God made. And I'm going after making it look very lifelike, very real, just like like a human. And if it looks exactly like a human, then it's going to be very beautiful because humans and things of nature are much more attractive than man-made machines are. I mean, some man-made machines can be considered beautiful, but I'm just going for lifelike, which is why I'm going to great pains to research anatomy and make like every little detail of the bones anatomically correct. And the way the muscles move then will look correct. The way the bones move will look correct because the joints are the same as human joints. I'm not taking like a machine and I'm trying to make it move like a human. That would be like not possible because it's not it's not structured the same. But by making all the bones and stuff the same as a human, it's going to naturally look and move a lot more like a human. I guess the reason I'm doing this is I really want a robot like as an assistant, like to build things or help me with things or help me with projects or even just cleaning, even like household menial chores. And I do have experience already with artificial intelligence. I've already coded like certain artificial intelligence stuff, so I have a background that gives me confidence that I can do a lot of what I have planned with this. Like, I have the code to back up the cool sculpting skills. I'm not just gonna like sculpt some really nice art project and then not know what to do once it comes to coding it. Let's see. If I ever try to make a robot based on a living creature, I would choose an insect. Yeah, I mean, that would be awesome, but I'm not just going for awesome. Like I was saying, I want this, like an insect can't mow your lawn, an insect can't do your dishes, an insect can't babysit. So that's why I want a humanoid robot. I want it to be actually able to work and make money too. Like wash my car, do all this stuff. So I want mine to be practical and useful. But an insect would be awesome. I just I don't have time to make like a whole bunch of robots. Actually, this is my first and only robot. Well, I might make something after this, but this is my first robot. I'm definitely, you know, you're supposed to take like little robotics tutorials and make like little toy cars and stuff and work your way up over the years. Nah, forget that. I'm just going straight to the full-on Android humanoid robot. Oh, yeah, easier to start with a child. I actually thought of that. You know, because servo motors are not that strong and their size to weight ratio is not that good, a child would be ideal because having smaller arms and stuff, you need less muscle to be able to do the same things. Like, think of it, like, if you took a gigantic robot, that's going to take a lot more power just to even move it around. So the smaller the robot, the better that cheap hobbyist servo motors that are affordable, like this. Oh, am I in the frame? Where's the frame? This kind of servo motor, like $10 or $6 on eBay. It would probably work better with a child, but I'm just going to use like a whole bunch of them. Like for a bicep, it's going to take like 10 of those motors to be able to generate enough force to lift like a 6-pound weight in the hand, called the payload. I think the human shape has much to be improved. Well, you know, anything you changed about the human shape in your robot, everyone would be like, oh, that looks wrong. Like, a human doesn't look like that. We compare everything to humans. So I wouldn't want to change anything because then it would just look off. Even if, like, having 4 arms would be awesome and it would be able to be more productive, it would bother people. It would look kind of repulsive to see something that looks like a humanoid with 4 arms. It would be disturbing. You know what? I'm going to be falling into that uncanny valley hardcore. It's going to happen, and I'm looking forward to that. Like, it's going to be cool to have that uncanny valley. I think the uncanny valley is awesome. Some of the internal structure. Oh, okay, yeah. The internal structure, definitely, this robot's going to be a lot different in the internal structure. For example, it's not going to have any stomach or intestines. It is going to have some artificial lungs for cooling. And I have this system where the lungs will expand and contract, motors will just kind of open and close like an accordion. And that's going to draw in air through the mouth and nose. And when it contracts, it's going to pinch off the intake, and it's going to blow air throughout the whole robot. And then we have vent tubes throughout the whole robot, so it's going to send cool air to displace all the hot air. So it's going to be really cool. But yeah, the rest of it's just going to be full of circuit boards and motors all over the inside of the body. It's not going to have organs and stuff like the human does. Useless bones and muscles or flaws the evolution left us. Yeah, we might have some of that stuff. I don't know a lot about useless bones, but there could be. Artificial lungs for cool. Yep. Thank you. I'm not a genius. I'm just a problem solver. Like, I'll just think about it and think about it. I'll be laying in bed for hours thinking, like, how do I solve this? One of the biggest problems this one guy that made a humanoid robot is he said that it kept overheating, like it had skin, and all the little servo motors inside it would be like burning out and actually destroying themselves, melting, because there was no air escape. Now you can poke little holes into the skin, but then you're letting in dust, you're causing all kinds of problems. But artificial lungs with a ventilation system solves all of that.